Hello everyone, welcome to part 8 of my series about vSphere with Tanzu on NSXT. Today we are going to create a service type load balancer in order to expose our NGINX application or web service. We are using NSXT as the software-defined networking solution, and we're going to look what objects are going to be realized in NSXT. First of all, remember that in the previous videos we create a deployment where we specified a number of NGINX web servers to be deployed. I'm going to use 3 replicas in this case, and if we check the deployment, we should see all the pods running. So they're free running at the moment. So obviously these NGINX web servers are not reachable as of now. They are not exposed through a service type load balancer yet. So that's the goal of today, to create a YAML file where we're going to specify a service type load balancer. Note we're going to need the metadata, the labels I've added in the deployment to find the pods automatically for the load balancer. And I'm using the NGINX app label as metadata to group the pods matching that label. So this is the manifest file for the service type load balancer. Here we have the kind service and here the type load balancer. We want to listen on port 80 in this example, and the target port is port 80 because the deployment is running the web server pods on listening on port 80. So nothing special here, and we use the selector app NGINX to find all the pods we need to expose on port 80. So pretty simple example, and I expect this service to be picked up by NCP, and this will create a load balancer instance on the namespace, in this case namespace alpha, and we can check in NSXT how that looks like. So let's apply this YAML, NGINX service load balancer. And now we see that the service type load balancer is created. So let's check the details. kubectl get service. So now we can find the name NGINX service load balancer of type load balancer, the internal cluster IP, and it's currently waiting for an external IP. So that's pending at the moment. This means that the container plugin is waiting for an IP allocation from the NSX manager. So the NSX manager is the IPAM solution in case of vSphere with Tanzu on NSXT. So now we can see that it has allocated an external IP from the ingress IP pool, meaning that the NSXT manager has allocated the 192.168.121.2 as an external IP for the load balancer. This also means that our load balancer instance will be created in NSXT. In my lab, this took a minute or so. So keep that in mind. There's some objects being created before it can actually give this external IP in the kubectl get service command. So yeah, you will see it will remain pending for a minute or so. And let's check how this service is composed. So if we do a describe service NGINX service load balancer, we can find all the details. So namespace in alpha, the labels are app equals NGINX. So annotation, so this is done by NCP, internal IP, and then service type load balancer, and the ingress IP, the port, the target port, the node ports, and the endpoint. So these endpoints are obviously discovered based on that label. And here you can see events. So you should see a normal event where it says successful realized NSX resource, meaning that the NSX container NCP pod is able to create successfully in NSX a resource for service type load balancer. Now let's have a look what objects are being created in NSXT. I always start in the inventory page for containers. So for the alpha namespace, we now see 3 pods, 1 service, and 5 networking objects being created. In this case, since it's a service type load balancer, I'm looking at the Kubernetes services. So if I click on this little link, I now see the service name, Nginx service load balancer, with 2 networking objects and 1 label. And I'm interested in the networking objects. And in this case, I want to know more about the load balancer instance being created. So this is the cluster IP automatically being created in order to discover the pods across the host. But I'm looking at the specific load balancer instance being created for this service type load balancer. So here you can see the server pool. Clicking on the server pool, I can find the 3 members of the server pool, and this is obviously the Nginx pods being discovered automatically, listening on port 80, and a virtual server, which is attached to the load balancer. And here you can see the ingress IP 192.168.121.2, listening on port 80 as layer 4 load balancer, and the link to the load balancer itself. You can also find statistics for the load balancer here if you like. So obviously you can also view it from here, from the load balancing page. You see a small load balancer instance being created, and this is the alpha load balancer in this case, and find the virtual server details here. So let's scale the deployment and add an additional replica for the Nginx deployment and see what happens. So let's do kubectl apply -f Nginx deployment. So now it will scale out, adding another replica. So you can see here, there's 1 pending. So wait for that to complete. So now it's complete, it's running. It has allocated a .34 IP from the IP pool for this namespace. So if we do a kubectl describe service Nginx service load balancer, we can see there's an additional endpoint being added based on the app equals Nginx label. And let's see if NSX automatically has added this new pod to the server pool. So clicking on the virtual server again and on the server pool, you can now see it has 4 members in the server pool. So that's automatically being recognized by NSXT as well. So to conclude today's demo, I would like to show if we can actually reach the external web page. So again, this is the IP listening on HTTP. And here we can see it's actually able to reach it. And this shows that through the NSXT layer 4 load balancer being created with vSphere with Tanzu, we are able to expose pods to the external network, and we're able to reach it. And this concludes our demo for today. Thank you for watching. Hope you liked it. Any feedback is appreciated. And until next time, thank you.